Good morning, my beautiful people. I'm Sotadeology. In today's video, we're going to actually dissect Sotadeology Lecture 5, the Interlocking of Dimensions, Part 3. So now this is going to be, the continuous part of the previous video. And so by applying this formula of everything, we have solution that is interpreted as static and undulating field, and that is the instant trajectory of time that we have at the central point right here. So now, that line can only be interpreted as static and undulating field because the reality of the universe domiciles in fields. And so if we're to look at the instant nature of time trajectory, it has to be disruptive. That is, it has to be something that is, invincible. The way I like to see it, it shouldn't be something that will be elongated. But basically, if it is not elongated by any form of energy, then it will not be measurable. And so we can see that even though there is trajectory of time instantly, we still have a kind of energy system that elongates it for time trajectory to be measurable. And so basically we have that as field. So now we're going to continue from where we stopped in the previous video. But before we do that, we need to understand that even though we're to have a gauge field, because when we're like trying to dissect the nature of symmetric nature of systems that are far apart from each other, we need to use gauge field. And what gauge field will do is just to ensure constancy, to balance the irregularities that may actually happen in between the vast distance. So definitely when we look at this instant trajectory of time, the essence of that elongation, we just have to be, number one, to synchronize the differences in the vastness of the distance for us to have that instant trajectory. Based on the Einstein discovery, we know that when we're talking about relativity of simultaneity, it is very difficult to have global now, you understand. But when we look at it, global now must be in place for us to have the reality of the universe. Because when we look at the instant trajectory of time being elongated by an energy, at a point where we're supposed not to have, energy intervention in the system, what that is telling us is that space is a fundamental property of the universe. So we can see that by having a kind of system that, prevent us from having absolute instancy, actually proves that space is an integral part of the universe. And so I think we should have a kind of energy balance to synchronize the differences in vastness of distance for us to really have this instant trajectory of time. Now we say we have instant trajectory of time simply because the force of weak conveying force actually travels through zero. It travels through zero. Now in classical system, when the force is said to be zero, we know that it is constant. So when you now have a kind of force trajectory that travels beyond, which is through the zero beyond, we know that we have that instant nature of time. So now I'm not going to go deep into the relativity of simultaneity to, I have explained that in one of my previous video. If you want to know more about that, you can, get the video to know more about it. So now let's briefly look at, the 5 conditions that must actually be satisfied to prove the eligibility or to validate the visibility of formula of everything, where in the previous video I stopped at number 2, which is this. Okay, the first one is Louis de Broglie hypothesis, which says that the circumference of electron's trajectory must at one point intersect the trajectory of that of the nucleus for us to have the standing wave, and then by having standing wave, that will give us mass formation phenomenon, and that is what actually ensures the suspension of electron to the nucleus, or rather the suspension of nucleus such that it doesn't travel into the singularity. And then the second condition is energy conservation law, which means that we should have symmetric nature in the universe. And so the symmetric nature that we have in the universe is like the structural framework of the universe in the time energy wave interactions. So now we know that in the Schrodinger wave equation we have symmetric nature because this refers to Hamilton total energy equation. That is, this is the total energy equation. It must be equal to kinetic energy and then the potential energy. This condition must actually be satisfied before we can say we have formula of everything. And so here we have the third one, principle of linearity superposition. So we have that to be this particular condition is highly essential for us to have interference of the wave pattern, or to really have that emergence of wave pattern. So now when you look at this model, this now, nothing like this is being well modeled in the Schrodinger wave equation, but it is thoroughly modeled in the formula of everything. It is thoroughly modeled in the formula of everything. So this will now allow for, so you can see that we have coefficients to wave 1, we have coefficients to wave 2. So, and that will serve as the total trajectory or the energy of the wave. So when you look at what we have here, we have coefficients to mass, then coefficients to weak conveying mass, coefficients to strong conveying mass here, and that will be the total. Well, in this case, it is not equation, this is a formula, you understand? So this will actually be nested right inside the time energy wave interactions. So now the fourth one is evolution of constancy. So it is mandatory for us to have that evolution of constancy in the system, because at classical level we have velocity to be constant by having force to be 0, you understand? So but now that evolution of constancy, we have it right inside the Schrodinger wave equation because of the discrete nature of energy, in form of energy levels. And then basically we have that in the time energy wave model that we have right here. In fact, it is been well portrayed in this time energy wave model. We can see how it evolves from the singularity of the Big Bang, and this is the trajectory of gravity, this is the trajectory of light, and then we see how that equilateral triangle is being flipped into the black. Also, now we have that in the formula of everything. So now the fifth one, which is the emergence of flipping at complex level. That is, we should have a situation where we have trajectory through the 0 instead of being stopped at 0 beyond to the complex level, you understand? So now formula of everything actually models this quite all right, by having this instant trajectory of time, and we can see that that trajectory is actually beyond the quantum suspension to connect to the real quantum mass. In this case, it is positron. Well, we have an indication of complexity in the Schrodinger wave equation, but that is not in any way being proved to be, highly visible. And so now basically, if I'm to actually run through the grading, then let's quickly start from the Louis de Broglie hypothesis. So that says that we should have a standing wave. You understand? So Louis de Broglie hypothesis says that matter, mass, particle should have inherent property of wave. You understand? And so this is going to, the lambda that we have here, we have, as the wavelength for any particle, matter, or mass. And then it says that for us to have the suspension of electron to the neutron, the circumference of electron must be equal to the circumference of, the whole number times the wavelength of, what is it called? Nucleus. You understand? So by that we have standing wave, and that is a point where we have convergence of mass beyond the symmetric nature of the universe, which is beyond the speed of light. And so now for us to gauge that, we know that we just have a situation where the wave function collapses. You understand? And then we know that we're going to have particle, but that is not being systematically or mathematically or thoroughly proved in the Schrodinger wave equation. That is why Schrodinger wave equation has 5 as its mark for grading here. But now, if we're to look at formula of everything, we can see that that one is being thoroughly proved. I want us to use the one on the board for us to get what I'm trying to say. So now, the standing wave has to be from this, where the quantum suspension is, up to this region of the wave. You understand? So now, this standing wave in the black body radiation, we have it to be the interception. Yes, we have it to be the intersection of, the wave that is being generated from the electron of the box to the wave of the laser beam. You understand? So where they now intersect, there is going to be standing wave, and that will be a kind of static and undulating wave that is not moving moving outwardly or moving inwardly. It's going to be static. So that kind of wave is what we're trying to prove right here. So when we have that kind of wave, it's going to be beyond this symmetric nature. You can see that what we have here is arbitrary quantum suspension, or quantum arbitrary suspension. So the real mass world is outside the time energy wave model. So inside this region is where we have mass convergence. Now, because photon is massless, there is no form of mass here. As this light trajectory is moving inversely to the gravity's trajectory, there is still contraction that generates radiation, and that supports the mass accumulation. And we could, term that energy conservation. You understand? So now, when you look at what we have here, the kind of flipping that we have here is so profound. So now, here we have suspension. Because we have convergence, immediately after the end limit of the constancy of light, we can actually term that to be the actual value. The actual value of the suspension is this, which is let me use this. Let's use this one. So now the actual suspending value is this, and that, because we have convergence here, we can substitute that in the formula of everything in the place of this m and this m. When we do that, what we're going to get is going to be this particular value. And then you can see that this value is way more bigger than this particular value. And that shows how the mass convergence is increasing toward the 0 point of the wave. So then what that is telling you is that as narrow as you have towards the 0 point of the wave, then bigger the mass density. You understand? That is what that is telling us. You can see that the system that we have here has to increase mass towards the 0 point of the wave in order to fight against the contracting nature that we have right here. So that is that. So the mass convergence which we have in form of standing wave is thoroughly proved in formula of everything than the way we have it in the Schrodinger wave equation. So the mark is 10 for formula of everything. So I want us to briefly see, the region is going to be like this. This beyond region of the quantum suspension is going to be like this. You can now see that we have a small equilateral triangle here, and that is referring to the compacted nature of the nucleus. So we can interpret this region to be nucleus. We can interpret it to be yes, we can interpret it to be nucleus. We can interpret it to be the suspending neutron star suspension in the black hole. We can interpret this to be the inflationary suspension in the Big Bang expansion, and we can interpret it to be nucleus as well. So this is going to serve as what we have here is the nuclear fusion, and what we have here is the nuclear fission. So the structure is being compacted down here, and it is also being compacted here. Now the difference is that the degeneracy pressure of this one is towards the edge boundary, and we have energy density here. So the degeneracy pressure here is towards the central point, and so we have mass density here. So now the second condition is energy conservation law. We have energy conservation law in the Schrodinger wave equation because the total energy is equal to the kinetic and potential energy. So now in the formula of everything, we have conservation law. Okay, so now you can see that the second one is energy conservation law. So that is being conserved in the Schrodinger wave equation because the total energy is equal to kinetic energy and potential energy. But in the formula of everything, we have that conservation we have that conservation law by having the radiation of this light trajectory to buttress the mass convergence at classical level. So this whole region is the quantum region, while this whole region is the classical region. And so we know that we have mass convergence here, while we have decaying of mass here, because we have all that right here that must be decayed through, and so the real mass world is suspended outside, while the real mass world is right inside the arbitrary suspension. So that is the difference. So now it is being thoroughly proved here. It is being thoroughly proved in the Schrodinger wave equation and thoroughly proved in the formula of everything. So the mark for this one is going to be 10 for Schrodinger and then 10 for formula of everything. So now So far, Schrodinger has 5 mark up here, 10 mark here, 15, 10 mark here for formula of everything, 10 mark here for formula of everything, 20. So now the third condition is principle of linearity superposition. Now this one is so essential because it's something that we allow for interference for us to have the wave pattern. And so now by looking at this, we know that we have a linear solution by having this, and that is basically saying that linear solution should be equal to the wave totality. Well, for Schrodinger wave equation, that, wave pattern we have curvature, then linear solution will not be curved in any way. I can't really say how that will be true for the Schrodinger equation, but basically it is Schrodinger equation. But one thing that I don't really understand here is that, we have the first order derivative for time in Schrodinger wave equation. We have second order derivative for space. Well, what that is telling us is that the second order derivative of space will indicate that the space is contracting. You understand? Why this first order derivative for time will indicate that time is actually, spreading out. So basically, that contradicts the equation in a way. So basically, what I'm trying to say is this: if we go back to the time energy wave model or formula of everything, this portion represents the second order derivative of space, that space is contracting, while the first order derivative of time actually is pointing to this particular phase, that time is spreading out. So in that case, it is not true there is a kind of discrete nature right there, that is, the wave pattern is not continuous, because space cannot be contracting while while the time is expanding. So the kind of relationship that space has with time should be time spreading wide, and also space should expand. But basically, what I would just have to say is that linearity is being maintained. So Schrodinger wave equation has 10. But now, when we look at the formula of everything, if you look at the structure itself, it's thoroughly models this. And so we can have the interference. Now, when we look at the time energy wave model here, we can see that the wave interaction of time to energy embedded the linear solution right inside itself. And so that is not saying that the linear solution is equal to the wave formation. You understand? So that is correct. So we have 10 mark for formula of everything there as well. So the fourth one is evolution of constancy. Well, actually, when you look at this, there is evolution of constancy for Schrodinger wave equation based on that, symmetric nature of equal total energy to kinetic and potential energy. You understand? So it has 10 mark. Then we know that we have the evolution by looking at the equilateral triangle, the evolution of equilateral triangle, and the contraction of equilateral triangle in the formula of everything. So that has 10 mark as well. So the last one, which is emergence of flipping of complex level, though Schrodinger wave equation has that imaginary number, but that is not being thoroughly proved in the formula. So then only formula of everything has 10 mark right there, because we have the time trajectory traveling beyond the quantum suspension to connect to positron. So that is that. So, well, that is that about this. But basically, let me briefly explain this.